Over the years, our 2007 Silverado has been asked to do quite a few things that it wasn't really optioned for. It was built presumably as a fleet vehicle, and it didn't come with a receiver hitch installed. Before I purchased it, it had an aftermarket trailer wiring harness installed as well as a hitch receiver. For whatever reason, that receiver was taken off before it got into my hands, and I later installed a CURT Class 4 receiver. So the truck has been upgraded with the ability to physically attach a trailer, but that's not the only option you would want for the truck for towing use. The biggest thing the truck was still lacking was an auxiliary transmission cooler. In all of the automatic transmission trucks, the transmission fluid flows out from the transmission through the side tank of the radiator and back to the transmission. This allows some warming up of the fluid for cold climates and some cooling down of the fluid in warm climates, and in a lot of applications it is enough to get by. For this truck, with just the radiator transmission cooler, the transmission temperature on a long highway drive would average around 190 degrees. And that's with no trailer or a significant added load to the truck. At lower speeds or on hotter days, the transmission temperature would climb significantly higher than that. The highest I think I ever saw it was 230 degrees on a 100-degree day stuck in standstill traffic. But with the heavy trailer behind it, the temperatures would still climb that high, traveling at highway speeds. The first time I noticed this was back in 2014 when towing home the 1978 Firebird I had just purchased in Ohio. Driving back east over some parts of the Appalachian mountain range really got the temperature to climb. Despite the cool evening October weather, the temperatures still climbed above 225 degrees. Ideal automatic transmission fluid temperature is going to change quite a bit depending on who you ask, but my understanding is that somewhere between 170 and 200 degrees is the most desirable for the longest fluid and clutch life. Older conventional oil transmission fluids would start to break down significantly at around 230 degrees, but the newer synthetic fluids should be okay up to more like 280. But just because the fluids are more resistant to those levels of heat doesn't mean it's a good idea to get anywhere near there. So to help keep things cool, we're going to be installing an aftermarket auxiliary transmission oil cooler. This Hayden cooler is most likely a similar size and design to what would have come in the truck from the factory if it had been equipped with the towing package. We could have gone with a slightly larger cooler, but since the truck has the 4.8 liter and it's only rated to tow 6,000 pounds anyway, the smaller one that was a little bit cheaper seemed just as good. We were able to pick this up for about $35. This is a plate and fin cooler, which is a little bit more efficient and compact than a cheaper tube and fin style of cooler. To go along with it, we have this special fitting which will help us connect a hose to the radiator, and some 11/32 inch ID transmission cooler hose. The fitting and the hose together cost about $15, so altogether we're looking at about $50. These universal coolers are pretty inexpensive and easy to find, but the downside is you have to figure out how to mount it yourself. To give our new cooler access to the coolest air possible, we'll be mounting it in the traditional position in front of the radiator. To get to the front of the radiator, we'll have to pop loose this plastic cover. It's held in with a handful of these plastic clips that can be easily popped up and removed with a flathead screwdriver. And once all those are out, that cover will lift straight up and off. Now we can see the radiator and the AC condenser mounted in front of it, but to get better access, we'll also be removing the grill. This is held in with 4 bolts along the top edge, as well as a few built-in clips. We'll pop these loose carefully by pushing outwards on them one at a time so as not to break any. These can be a bit fragile, so it's a good idea to take your time. And once everything has been separated, we can slide the grill out. On this truck, it's a bit sandwiched by the push bar, but it's still not exactly difficult to remove. And with all of that out of the way, we finally have good access to where we want to mount this cooler. We'll hold it in place and eyeball everything, trying to get a feel for how we're going to route the hoses. The design of some of the structure at the front of the truck limits the mounting options a little bit, but there are some nearby unused bolt holes that I think we'll be able to take advantage of. This position looks about right, but before making any bracketry, we'll work out the positions of the hoses and make sure everything can actually reach it. And we'll start that in the top corner of the radiator, right here. This steel line connected to the radiator is the return line for the fluid from the transmission. The transmission pumps out oil into the bottom of the radiator end cap all the way up to this port, and then, having been cooled, it flows back into the transmission. We are going to be splicing into this connection to install the auxiliary cooler. To disconnect this line, there's a black plastic cover we'll slide back, then a spring clip that we need to pop loose. We'll be using an angled pick to do this, and since the access is pretty decent, it is not difficult to remove. Just make sure to hold on to it so that it doesn't launch off into oblivion. And here's that tiny clip that holds the line in the fitting. It's a little hard to see, but right above the fan there's also this little bracket that's holding the line in place. We'll loosen the bolt and separate the bracket from the line. Then, with a paper towel held below the fitting to help collect any drips, we can separate the line from the radiator. And that's all it takes. The cooler line fittings that GM uses are pretty nifty. And that's exactly what this special fitting makes use of. There are other ways to make this connection, but I feel like this is the most simple. We'll apply a few drops of ATF to the fitting and install it into the radiator. And we can reinstall the locking clip. And on top of that will go the plastic cover. Just like that, we have a barb fitting that we can attach our transmission cooler hose to. So the hot transmission fluid will flow up through the radiator and out of this brass barb fitting. Then the fluid will travel through a hose out to the front auxiliary cooler, then back through another hose into the factory steel hardline, which means we have to position this hardline so that we can attach a hose to it. This is how the angle looks right now. We'll need to reposition things just a little bit to get the hose to route around the end tank of the radiator. And to help hold the hardline where we need it to be, we'll take the bracket that we removed and give it a bit of a tweak. We reinstalled that and checked the fit, but it looked like it still needed more of an angle. So we'll use the vise to get it all twisted up. This time, when we reinstalled the bracket and hooked up that hardline, it was actually facing fully around the end tank of the radiator. So it looks like that angle will work for us, and it's still well out of the way of the radiator fan and anything else it shouldn't be touching. We'll call that good enough for now, and we'll come back to cut and attach hoses to those fittings once we have the auxiliary cooler mounted. To figure out how we're going to do that, we'll do some more eyeballing of the position, make up some little cardboard bracket templates, and once it seems like we're on the right track, we'll transfer those markings onto an 1/8 inch thick aluminum strap. We'll clamp that in the vise and use a square to make sure it's perpendicular to the vise jaws. Then, with some pressure and a rubber mallet, we'll knock it into approximately the angle we're looking for. Then we'll measure it, mark the length, square it up again, and bend it the opposite direction. So now we have this little S-bend. We'll drop the cooler back in and make sure the angle and length of the piece is what we were looking for. It's looking pretty good, so we'll take it back to the vise and cut our piece from the strap. Once the sharp edges have been rounded over on the belt sander, we'll clamp it back into the vise and drill a hole in each end for a mounting bolt. We'll deburr each of those and then go in for another test fit. With the cooler and its bracket in place, we'll slide through mounting hardware and tighten down a bolt and lock nut to this existing hole in a part of the core support, followed by tightening down a bolt and nut on the other end of the bracket to hold the cooler to it. And that seems like a decent fit, so the mounting on that corner should be good to go. But of course we're going to need a little bit more than that to actually hold it still. Finding an existing nearby mounting hole for this upper corner was a little bit trickier, but we didn't have to go too far. I ended up choosing to cut a slot through this diverter material so that I could run the bracket through it. Just like last time, we'll make a template out of cardboard, and we'll do some more aluminum bending. Pretty soon we have our bracket looking like this. It'll connect that upper corner of the cooler all the way over to this part of the core support. So again, we'll cut out our part, drill it for the mounting bolts, and install it using bolts and nuts. and once it's in place on both the vehicle and the cooler, we'll tighten those down. Once they have been, it's certainly better than it was with just the one bracket, but the cooler is still a little bit floppy, probably due to the length of that last bracket. But that's no matter, we will just make one more bracket. We decided to use this existing hole for the passenger side bottom corner, although we will need to enlarge it just a little bit. Then we'll use a tap to cut threads for our mounting bolt. Since the material's pretty thin, this won't be the strongest mount in the world, but it really doesn't have to be. Next, we'll make, you guessed it, another cardboard template. Making brackets sure tends to turn into a bad obsession. For this bracket, we'll need a 90-degree bend. In my experience, to make a tight 90-degree bend in aluminum like this, you really need to add some heat to prevent the material from cracking. So we'll get it warmed up with a propane torch, start the bend, warm it up a bit more, and knock it into the angle we're looking for. In fact, I went too far there, but since it's still heated up, it's not a problem to bend it back a little bit. And now we'll drill another hole, trim a bit off the corner, drill one more hole, and then we'll make sure it all bolts together. We'll spin in the first mounting bolt to the threads we cut, then use yet another bolt and nut on the other side of the bracket to hold it to the cooler. And once that's been tightened down, we'll give the cooler a good shake. It feels pretty solid, and once the hoses are installed, they should help dampen some of the vibrations, so I think we're going to call that good. Next, we're actually going to take everything apart again so that we can clean the brackets up a bit and give them a coat of paint. We'll round off all the unfriendly edges using the belt sander, and once the brackets are nice and smooth, we'll brush on a quick coat of bed liner. The aluminum doesn't really need any of this, but it'll kind of help the brackets blend in if you were to look through the grill. We'll give those a few coats and let them dry for a few hours, then we'll get back to installing the cooler, this time for good. Pretty soon, the cooler is fully mounted. Finally, we're ready to install the hoses, so we'll take the protective caps off of the cooler. It happened off camera, but I did run some ATF and brake clean through this cooler to make sure that there wasn't any debris stuck inside of it. It would definitely be a shame to introduce contamination to the transmission through this cooler. But having cleaned that out, we're ready to install the hoses and complete this cooler installation. We'll put a few drops of transmission fluid into the hose and then slip it over the barb fitting that we installed in the radiator. And once the hose is fully in position, we'll clamp it down. We're using a fuel injection style clamp for this, and if we had enough we would have used them for all of these connections, but we have worm gear hose clamps on the cooler side. There's not a tremendous amount of pressure coming through these lines, but the fuel injection style clamps would probably be a better fit. With the clamp tightened, we'll feed the hose through to the front of the core support. We need to make sure that the hose isn't angled too severely, so we'll leave some slack when we cut it. We'll install the other end of that hose onto the lower fitting of our auxiliary cooler, and then we'll repeat the same process to install the other hose between the auxiliary cooler's upper port and the return hardline. We'll finish tightening all of the hose clamps, and the installation is complete. We'll double check that neither of the hoses are angled too sharply or rubbing against any bare steel, but everything is looking good. I ended up cutting little notches in the diverter for the hoses to pass through. None of this was necessarily the simplest way to install this cooler, but since it's on the passenger side, the hoses are kept as short as possible, and having the cooler right up against the condenser should be good for airflow. There's one thing we need to do before we put the truck totally back together, and that's checking for leaks. We'll start the engine up and let it idle for a minute or two to make sure there aren't any immediate problems. And luckily, just like every other time we've messed with transmission cooler lines, there are no leaks. So we'll reinstall the grill and the plastic cover in reverse of the way that they came off. And the truck is ready to get back on the road. We installed this cooler a little over a year ago, and in the time since then the transmission temperatures have been much better. The average driving temperature has gone from between 190 and 210 degrees all the way down to 170 to 190 degrees. At one point, I got stuck in standstill traffic when it was 90 degrees outside, and the hottest the transmission got was 205 degrees. So even in that worst case scenario, with the only airflow being from the radiator fan, the transmission still stayed cooler by about 25 degrees. The Silverado was also used to haul another vehicle on hilly roads in hotter weather but otherwise similar conditions to when we towed the '78 Firebird. And instead of staying between 215 and 230 degrees, the hottest the transmission got was 190 going up hills, and when coasting down hills it would cool all the way back down to 175 degrees very quickly. Over the winter, though, the average transmission temperature was somewhere around 150 degrees. On colder days, even on relatively long highway trips, the transmission would struggle to get above 130 degrees, which is why I chose to install this as an auxiliary cooler and kept the radiator cooler in line. On colder days, the engine coolant will actually help bring the transmission fluid up to temp. As mentioned earlier, ideal temperature is probably between 170 and 200 degrees, so those 130 degree temperatures in the winter aren't really ideal, but it would be much worse off if it didn't have the engine coolant helping to warm up the transmission. Though in our area, for most of the year, the temperature on a longer drive is in that normal operating range. So I've been very happy with this cooler, and I think I chose the right size for this use. And for a total of about $55, including the brackets and hardware, I think it is definitely a worthwhile upgrade.